Welcome back. This is an Aleks training video on predicting the relative stability of ionic crystals from a sketch. Positive charges repel each other. Negative charges repel each other. Positive and negative charges attract each other. Okay. Coulomb's law, which we studied in physics, is really helpful here. Coulomb's law, which looks a lot like Newton's law of gravity, says that the attractive force, which he called E, is equal to some constant times the amount of the first charge. Okay, so let's say it's a positive 1 charge times the second charge, say it's a negative 1 charge, divided by the distance they are apart. Okay, so since this is negative k, your energy is going to be negative, very big negative, okay, big negative, if your charges are large and your distance is small. Okay, so the more negative the energy, the more stable it is. Think of it as a rock is falling down the mountain, the lower the height of that rock, the more stable it's going to be. When it hits the ground, it's done. It's completely stable. Same thing here. The more negative this is going to be, the higher this E negative will be, you're going to end up with more stable. All right. Now, if it were a positive energy, that's very unstable. For instance, if you've got two charges that are one that's positive, one that's negative, you are going to you're going to attract positive times the negative, and you want the most stable. So you want the lowest energy that you can have. So if that makes sense to you, I hope, we're looking for stability. We want them to be close together. So these guys are very close together. Those would be very stable. This one is a little farther apart, so this is slightly less stable. And these are all positives and negatives, which is very stable. These are positives and negatives, which are very stable. These are lots of negatives together. You can tell that those negatives are going to repel each other, so that's going to be very unstable. So you're looking for positives and negatives. You're looking for very close, tight crystals, and you're looking for biggest charges as you can get. Okay, so the biggest charger would be the most stable. Okay, so with that being said, which one is the biggest stability? Which one is the most stable? Closer together, so that would be, A, B, and C are close together. We want opposites, so that's A and B, and we want the highest charges, that's A. So A will be the highest or most stable. So let's do it this way, most stable. C will be the least, because you've got all of these negatives here that are repelling each other. All of these guys are repelling each other, and that's going to want to break the thing apart. It's not going to want to make a crystal. It's going to want to shatter the crystal. So this would be 4. This is least stable. Now, what is number 2? So B and D are both negative, positive singles, okay, not doubles, but B is closer together, so your R is lower, okay, and your R is lower, then your negative energy is going to be lower. So this will be 2, and then this one will be 3, okay? I hope this makes some sense. Just pictures make better sense than words to me somehow. I like them better.